Hey, what's up, everybody? It's Ned Bellavance, Ned1313 on Twitter. Welcome to Terraform Tuesday. I hope you're enjoying your tacos. You know, it is officially a Taco Tuesday for me. We're going to have fish tacos tonight with red cabbage and onion slaw, a little diced jalapeno up in there, and we take some tilapia, cut it up, toss it in some spices, cook it in a frying pan real quick, and then serve it on corn tortillas. It's just delightful. I'm excited. Anyway, let's not talk about that. The topic for today is the official release of version 0.15 of Terraform. That's right. It was dropped a couple weeks ago, and I looked through the release notes and the changelog, and I have put together a compilation of things that I think you might be interested in. So that is what we're going to cover today. Two quick things before we dive into the topic at hand. Number one, my HashiCorp Vault certification course on Pluralsight is done. That means it was 2 courses as part of the path. Both courses are done and published now. So if you're interested in getting the certification and you want to jump on Pluralsight, you can do it. And if you do it in the month of April, it's free. So you can just go to Pluralsight and take the courses for free. So that's nice. You can't get around that. And the other thing that I wanted to mention is, I do a daily podcast. It's 10 minutes every day, and it's just some general thoughts I might have about the tech industry or advancing your career. It's called The Daily Check-In. The link is down in the description. Definitely check that out if you have time. I appreciate any feedback you might have. Now let's get into Terraform 0.15. People are often curious, how is Terraform not at a 1.0 release? That's a question that I've been asked, and I know that people at HashiCorp have been asked as well. I mean, people all over the world are using Terraform to deploy infrastructure hundreds or thousands of times a day. How is this thing not 1.0? And the answer is that HashiCorp thinks very differently about 1.0 than some other companies do. For some other companies, it might be sufficient to hit like a step above MVP and then call it 1.0 and be happy, as long as it builds consistently. Yeah, 1.0, we made it. That's not how HashiCorp thinks of it. And they do have a whole philosophy around it. And I'm not going to go through that philosophy right now, but suffice to say that they're not willing to put 1.0 on anything unless they feel that it is completely enterprise grade and there's not going to be any significant breaking changes in the near future, as well as some other things. So Terraform is inching closer to it, and 0.15 is a big step in that direction. The one thing that I noticed is that the list of deprecations in the changelog was long. And this is sort of their way, I think, of prepping for the 1.0 release is we've got to get anything that breaks stuff done. Anything we said we're going to deprecate, let's get it deprecated. And then we can move to our 1.0 release. So we want it to be fully mature. So I just wanted to run through those deprecations real quick. What are things that, are just not going to be there anymore? Now, in the dark days of 0.11, there was not a real data type system within Terraform. Everything was basically a string. You had numbers in Boolean, but really Terraform thought of them as a string. And the constructs like a tuple or a map or a list were things you had to be explicit about. And for that reason, there was a function called map and a function called list, which let you take a set of strings to create a list or a key value pair of strings to create a map. And you would have to do that explicitly if you then wanted to perform map-like operations on that object. So if I wanted to pull out all the keys of a map, I first had to declare that something was a map to pull the keys out. That was no longer the case when 0.12 came out and HashiCorp Configuration Language 2 dropped. Now there was defined types, and the way that you set something up as a particular data type was done in the syntax of the code. If I wanted to make a list, I would simply enclose a list of strings in square brackets, and that was it. If I wanted to make a map, I would use the curly brace and then have some key value pairs and then a closed curly brace. And Terraform would understand that's a map object and treat it as such. Those functions became redundant. And so HashiCorp said those functions are going away, and those functions are now gone. You can no longer use them in 0.15. So if you still have some old configurations laying around that are using the map or list functions, they're gone. You have to update it. You probably don't need the function at all, but if you really need to be explicit about transforming something into a map or a list, there is the new functions toMap and toList. So use those instead. Pretty simple, right? The next related item to data types was in the pre-0.12 days. When you wanted to define a data type for your variable, you would say type as the argument, and then you would enclose the type in quotes. You would quote the string. So if I wanted it to be a string type, I would say type equals quote string end quote. Once you move to 0.12, now those data types were supported natively, and you just say type equals string, type equals bool, whatever the data type was. And Terraform lets you do both for a while, no longer. So if you're using those quotes for your data typing in variables, remove the quotes, because otherwise Terraform is going to throw an error saying this is invalid syntax. So, just go through your code, see if you have an old config that uses that. Hopefully you don't. The next one has to do with HashiCorp's crusade against provisioners. If you're familiar with provisioners, it's the idea that when a resource is provisioned, you also want to do something else related to it. And usually this is running some bit of code either locally on your system or remotely on that system. And there's the remote exec and the local exec provisioner to do that. But there were also these third-party provisioners using Puppet, Chef, etc. And you could snap those in and have those run instead. Those are all deprecated. They've been deprecated for a while, and now they are gone. You can no longer invoke those. If you really need to run Chef or Puppet remotely or locally, use the remote exec or the local exec, because those third-party provisioners, they're gone. Another significant change was how they approach Terraform init. They've removed at least 4 arguments from Terraform init, and it has to do with the way that the required providers block has evolved. A lot of the things you might have done through an init flag are now handled by that required providers. And with the update of the Terraform registry and support for registries that aren't the public registry, now you don't need all those flags. And they've also added some security that's just on by default. So those switches are gone. Check which flags you tend to use with your Terraform init and make sure that none of the flags that you tend to use have been deprecated. It's only 4, and I don't think they were commonly used anyway, but definitely make sure to check. Lastly, and this one has been telegraphed for a while, so if you're still using it, time to change. There was a flag when you ran Terraform destroy that was -force, and that would get rid of the prompt to type in yes that you were sure you wanted to destroy the environment. It's a powerful flag. Now that was replaced by the -auto-approve flag. I don't remember what version exactly, but it was replaced by that. But they kept the -force flag around. The reason they changed to the new flag was so that it was consistent with the syntax for the Terraform apply command. They both use auto-apply. So with that in mind, if you are still using the -force flag instead of -auto-approve, time to go do a find and replace and get rid of that old -force flag. Otherwise, it's going to break because Terraform is going to say, that's an invalid flag. I don't have that one anymore. So that's just some of the things that have been deprecated in 0.15. Definitely go to the changelog and check out what else has changed, just in case it bites you. And there's also an upgrade guide if you're moving from a previous version of Terraform they put together that calls out some of these gotchas as well. Now let's get to the good stuff. Enhancements. What is new in Terraform 0.15, or what has changed slightly? The first one was a little hard for me to wrap my brain around, and it's configuration aliases in required providers. Now that sounds like a lot of gobbledygook, so let me boil down what the essential problem is, and then I've got a code example that we can look at that'll hopefully make things a little more clear. If you're using aliases for providers inside of a module, you would have to declare each provider. Now, just as a quick reminder, aliases are a way to have multiple instances of the same provider within a configuration. And you do that by having a provider block, and then within that provider block, you say what the alias is that you want to use to refer to that provider. Because of that, if you're using aliases inside of a module, you would have to declare each alias in its own provider block. And that's somewhat redundant. There was also some weird logic going in that if you passed in a provider and you did it in a certain way, it might not honor the alias. So what they decided to do was, rather than having the same provider block that was empty except for the alias a bunch of times, instead, they were going to add a list argument to the required providers area where you can list out each alias you want to apply to that provider. And then it kind of generates those provider blocks in the background for you, or at least kind of implicitly has those provider blocks. So now you don't have to list out every single block for every alias you want to use in a module. It was an esoteric ask, and it's a little confusing to me. So why don't we jump over to Visual Studio Code and I'll walk you through an example of how it actually works. Okay, here we are in Visual Studio Code. If you're looking for the files related to this video, you can always find them on my GitHub at the link that just popped up down on the screen for you. So just go to that link or look down in the description. It's in there as well. We're going to be looking in the folder 2021-04-20 Terraform 15. So it should be pretty obvious which one we're talking about. And we're looking at one of the enhancements. So I'll go ahead and expand enhancements. And let's take a look at what the folder structure is here. We've got a main.tf. Let me shrink that up. We've got a main.tf file here. Let's open that. And what this one does is it has our required providers, a location. We're using the Azure RM provider, and then we're invoking a module. So we're invoking a module that's in the folder sub, and we're passing it the provider Azure RM.sub to the provider inside of the module, which is also called Azure RM.sub. Okay, so now let's go over and take a look at what's in that module. So I'll expand that out and look at the main.tf in here. And here's the updated verbiage. In our required providers, under configuration aliases, we have a list of the provider aliases we want to create for this Azure RM provider. And in this case, I'm creating one alias called Azure RM.sub. Now, because it's Azure RM, you need at least one provider block in there that defines the features sub block. That's just a requirement of the provider. But you notice I don't have to then define a second provider block for the Azure RM.sub provider. I only have to define the provider once. And I can use both the defined provider, the Azure RM.sub provider, and the default provider. So I have a resource group here that has a provider argument in it, and we're using the Azure RM.sub provider alias for this one. And then we have a second one that's not explicitly defining a provider alias to use, so it's going to use the default Azure RM provider instead of the alias. So in that way, we can use two different providers within the same module. So that's the basic idea behind configuration aliases. If you're writing a lot of modules and you need multiple instances of a provider, then it makes a lot of sense. If you're not doing that, well, I guess don't worry about it. It's fine. What's the next enhancement to talk about? All right, the next thing is that Terraform format now considers unnecessary interpolation a formatting error and will remove that unnecessary interpolation. Now, you may be like, what does that mean? If you remember, in the old days, pre-0.12, whenever you wanted to parse out a variable or another value, a calculated value within a Terraform configuration, you had to interpolate it. And the way you would do that is have the $, curly braces, and then the value that you wanted to interpolate into a string. 0.12 removed the need to do that. So when you wanted to refer to a variable, let's say, you would just say var.location. In the old way, you would do quote, $, curly braces, var.location. So it just made the whole thing much more readable, and it was a big advancement with 0.12. Now, when Terraform format goes through, if it sees you've done that and it's not necessary for creating a string, it's going to remove that string interpolation. On the flip side, Terraform validate used to warn you about that all the time. Terraform validate is going to stop warning you about that because it's going to assume that Terraform format is taking care of those things. So in your pipeline, when you're linting your code, run Terraform format to format it, and then run Terraform validate to validate that it's good configuration. We could take a look at an example of that if you'd like. Let's go back to Visual Studio Code. In the main, I've got a locals value here, unnecessary interpolation, and this is the correct syntax, just var.location. If you want to set unnecessary interpolation to a value that's stored in var.location, that's all you have to do. In the old way of doing it, you would do quote, $ curly brace, add the other curly brace, and the other quote. And that is still technically okay. Like, that will render just fine in Terraform, but it's definitely not considered best practice or proper syntax. So if we go into this folder and run Terraform format, it's going to look at that and go, no good, taking it out. And so it removed that string interpolation, and now we have just var.location again. So that is basically what that enhancement does. Let's see, what's the next thing that's an enhancement? Well, the next thing is some improvements in Terraform validate. Now, I already mentioned one of them. It will no longer flag string interpolation because it's assuming format has taken care of it. Allegedly, it also will do a better job of picking apart improper configuration when it comes to plugins, or AKA providers. So if it sees an improper configuration, it's going to give you more context for why it's improper, as opposed to throwing out what might be a very hard to parse error. I wasn't able to replicate that, but hopefully it's in there and hopefully it's helpful to you. Another helpful enhancement for Windows users out there, yeah, that's right, fellow Windows users, we're getting some love. Terraform has moved away from using the classic Windows console API to the modern one that ships with newer versions of Windows 10. And that allows it to do a lot better formatting of Terraform when you're seeing output scroll past in the screen. So you may notice that colors are more vibrant, formatting is clearer, and all of those kinds of things. That is due to the change over to using the new version of the console. If you're on an older version of Windows that doesn't have the modern console, you can get around it. You just have to add the -no-color flag to your commands so it doesn't try to do this more interesting formatting. But I found already that it's easier to read through the text that's scrolling by when it adds this additional formatting. It's something I had when I was running in WSL that I didn't have when I was running in PowerShell. And now I have it. Yay! A few more enhancements to talk about. This one's interesting. Better reporting on plugin crashes. When a plugin crashes, now you're going to get better reporting out of that plugin to figure out what happened with my provider. Why did it crash? That was something that was not great before, and it's going to be better now. In addition to that, now you can enable additional logging for Terraform core or Terraform providers. So you can juggle what level of logging you want for both, and that's controlled through two different environment variables. So let's take a look at that now. Okay, we're back in Visual Studio Code, and I think I put this in the Azure RM backend because I'm going to be showing you this in a moment. But if you look under commands, here's the two environment variables that have been added. Now there's just TF log. That's a global setting. If you don't set one of these individually, whatever set in TF log will be the logging level that you'll see. But if you want to set one to a higher level or a lower level, you can override it with one of these two environment variables, TF log core or TF log provider. So if I am concerned about what's going on with one of my provider plugins, I could set that to debug, but set the core down to info. So I'm not seeing as much information from core Terraform, and I can really dig into what's going on with the TF log provider. Now, ideally, I would also want to split these into two different log streams potentially to better capture which is coming from where, but maybe that'll be a future enhancement. So if you set these two, you will see two different levels of logging for the two different components within Terraform. So that's kind of nice. The last interesting feature is an improvement in how Azure RM backend handles authentication. If you are familiar with the Azure RM backend, that basically uses an Azure storage account and container to hold your state information. And it's a fairly common way of handling remote state. Now, when it comes to storage accounts, there's many different ways you can authenticate to a storage account. You can use the storage keys, which gives you pretty much access to everything in the storage account. You can use SAS tokens, which are shared access signature, I think is what it stands for. But basically, it's a key that defines more granular control over what you can do, and you can time bound the token for how long it's good for. Or lastly, you can now use Azure AD to delegate permissions to a storage account through a specific role. Now, with these different options, until recently, the two options that worked with the backend was either using the SAS token or using the storage keys. It didn't really respect the configuration if you were trying to use an Azure AD role. That has changed. Now an Azure AD role is supported, and I thought I would walk you through and see how that would actually work. So let's go back to Visual Studio Code. Okay, and first we have to create a storage backend. So let's take a look at what's in there. What's in there is very simple. We're going to create an Azure RM provider. We're going to set a name based off of a random seed and a prefix that's supported through the variable. And that's going to be the name of the storage account and the resource group. And then we'll create that random seed, we'll create the resource group, a storage account inside that resource group. And down at the bottom, we are going to set the container that holds our state to the name state. So that's pretty straightforward. And then we're going to make a role assignment. And the role that we're going to invoke here is called storage blob data owner. And in this case, I'm assigning the role to myself, which that's not especially useful, but you could assign this role to any service principal in Azure AD. So maybe you have a user assigned identity that you use for your runner machines for your Terraform runs. You could assign it to that, and then since it has that role, it can now perform the state read and write to that location. You also give it a scope, and the scope defines where this role is applied, and I'm applying it at the resource group level, but you could apply it, I believe, at the resource level as well. So with that in mind, let's go into that directory. Where is it? Create storage backend, and we'll do, I believe I've already done a Terraform in it, but I'll do it again just in case. There we go. All right, and we can simply do a Terraform apply, and we'll do auto approve on that. There we go. And that will spin up my storage account and make the role assignment. And I'm getting my current object ID information from the data source Azure Client Config, which is a super useful data source. If you've ever worked with Azure, you'll know that's very useful. So once this is done, it's going to create a storage account in Azure, assign proper permissions, and create the container inside of Azure, the Azure storage account as well. Once that is done, we will move down to use Azure AD users. And in order to do that, we're going to have to set up the backend with the Terraform init command. So let's look at the main, and we'll look at the way that the backend is configured. We're doing a partial configuration there. And the way that we do that is we can add some information in here and then give the rest of the information at runtime when we run Terraform init. So I have 3 outputs from the Terraform configuration we just deployed. I'm going to copy those and put them in the backend data.txt file and save it. So these are going to be the 3 additional arguments that will pass over at runtime for the initialization. Within the actual config, all we do is state the container name, the key name it should use for the state, and we'll set use Azure AD auth to true. So it's going to use Azure AD authentication for the back end, and then we have to supply it the additional information. And the additional information we need is the storage account name, obviously, the subscription ID, and then the tenant ID of the Azure AD user or service principal that we want to use for Azure AD authentication. And then it could use MSI for that authentication, or it could be an authentication that's cached using the Azure CLI. I have my authentication cached with the Azure CLI, so I can simply run the command here, which is Terraform init. Well, let me get into the right directory first. So we'll go into the use Azure AD users, and we'll run Terraform init backend config equals backend data.txt, because that has my additional arguments in there. Once I run that, it's going to go out. It's going to configure the remote backend. Oh, looks like I need quotation marks. There we go. It's going to go out and configure the backend in the storage account using my Azure AD authentication. So you no longer need to juggle SAS tokens or access keys for storage accounts for state. So that is also, well, it's Pretty cool. So that's another enhancement that's out there. The last enhancement, and I really appreciate that because it's something that I've done, unfortunately, many times, is if you type Terraform destroy or apply and you're off by a letter or two because you're not the world's greatest typist, this guy, it will suggest what you might mean as opposed to just printing out the standard help list. And if that sounds interesting to you, I'm telling you, it's wonderful. I definitely recommend it. And so thank you to HashiCorp for adding that in. The last one that I wanted to talk about is a way of unit testing your Terraform configurations, your Terraform modules, and doing that using HCL and Terraform as opposed to some third-party tool. You might have heard of TerraTest, which allows you to unit test your modules using Go. Now, if you already know Go, that's awesome, but I don't, and you might not either. So wouldn't it be nice if you could actually use HCL and Terraform to unit test your Terraform modules? Yeah, that sounds pretty good. And that's exactly what this experiment is aiming to do. They've created a custom provider that's part of Terraform that will be used for testing. And this is an experiment. It may never end up in, GA Terraform, but I really like the idea, and I think it deserves its own video. It reminds me a lot of what happened with Pester and PowerShell, which Pester allowed you to unit test your PowerShell modules using PowerShell. Well, in the same way, this is a provider that allows you to unit test your Terraform modules using Terraform. It seems really convenient. So the concept is very cool. Like I said, I'm going to do a whole video on that, but that will do it for the list of what's new in Terraform 0.15. Well, hey, I hope you enjoyed this rundown of what's new and what's going on in Terraform 0.15. We are well on the way to Terraform 1.0, and if I were a betting person, I would say Terraform 1.0 is probably going to drop in Q3 of this year. I think it's going to take them that long. There might even be one more release between now and 1.0, but we're definitely going to get there this year. So that's going to be super exciting, and I'll do a whole episode on Terraform 1.0 when it comes out. That'll do it for me for today. Thank you so much for watching. If you want to support the show, please do. We have a Patreon that is available, and there are multiple different levels. If you hit the big burrito or the empanada level, you get your name up on the page. So that's kind of nice. And if that's not your thing, you can always subscribe to the channel. I really appreciate that. And if you want to share it with a friend, I really appreciate that as well. Until next time, stay healthy, stay safe out there. Bye for now.